The Earth, you know, is green and blue. It feels gentle, familiar. But much of our planet is anything but friendly. There are places where the air is toxic, where the ground burns, where pressure can crush steel, and where sunlight never reaches. Logic tells us that life should not exist there. And yet, it does. At the heart of this contradiction lies an element most people associate with death, decay, and poison. Its smell warns us to stay away. Its fumes can kill. Its landscapes look alien and hostile. And still, life depends on it. That element is sulfur. Humans have known sulfur for thousands of years. We recognize it instantly by its smell, the sharp scent of rotten eggs. For ancient civilizations, sulfur was a sign of danger, associated with fire, the underworld, and divine punishment. Volcanoes that spewed sulfurous gases were seen as gateways to hell, and from a human perspective, that made sense. Sulfur burns, sulfur corrodes. Sulfur poisons, but chemistry does not care about comfort, and life does not follow human intuition. Sulfur is unlike most elements. It is incredibly flexible in the way it bonds with other atoms. It can form long chains, closed rings, and complex molecular structures. Most importantly, sulfur can easily gain and lose electrons. That ability makes sulfur perfect for chemical reactions that release energy where oxygen is unavailable. Sulfur can take its place. This single property changes everything. Today, most complex life depends on oxygen. But early Earth did not have an oxygen-rich atmosphere. For billions of years, our planet was hostile, volcanic, and chemically violent. Yet, life appeared anyway, not powered by oxygen, but by sulfur. Now, imagine descending deep into the ocean. The light fades. The temperature drops. The pressure increases beyond anything humans can survive. At depths of thousands of meters, the ocean floor should be lifeless, and yet something extraordinary exists there. Hydrothermal vents crack open the ocean floor from inside Earth. Superheated water rich in sulfur compounds erupts into the sea. These vents look like underwater volcanoes. The water is toxic. The temperature can exceed boiling, and yet entire ecosystems flourish here, not because of sunlight, not because of plants, but because of sulfur. At deep-sea vents, bacteria perform a process called chemosynthesis. Instead of using sunlight like plants do, they use sulfur compounds as their energy source. Sulfur becomes fuel. These bacteria form the base of a food chain that supports giant tube worms, clams, crabs, and fish. An entire world exists, powered by sulfur alone. Life forms that thrive in extreme conditions are called. Many of them rely on sulfur-based metabolism. To them, sulfur is not poison. It is food. They live in acidic lakes, boiling hot springs, and toxic volcanic soils. Where humans see death, life sees opportunity. Volcanoes are among the most destructive forces on Earth. They reshape continents, darken skies, and wipe out ecosystems. But volcanoes also release vast amounts of sulfur around volcanic springs and fumaroles. microbial life thrives. These environments may resemble the conditions under which life first appeared on Earth. The early Earth was violent, constant volcanic eruptions, frequent asteroid impacts, little oxygen, but it was rich in sulfur. Many scientists believe sulfur chemistry helped drive the first metabolic reactions before plants existed. Before oxygen filled the air, sulfur may have powered the earliest living systems. Sulfur did not disappear when oxygen took over. It remains essential to life today. Sulfur is found in amino acids like cysteine and methionine. These molecules help build proteins, the machines that run every cell in your body. Your hair, your skin, your muscles, all contain sulfur. Sulfur forms special bonds called disulfide bridges. These bonds help proteins fold into precise shapes. Without sulfur, many proteins would collapse. Life depends not just on elements, but on how they shape structure. Sulfur teaches us something profound about life. Life does not seek comfort, it seeks energy. Wherever chemistry allows energy to flow, life will find a way to exist. Sulfur-rich worlds exist beyond our planet. Jupiter's moon, Io, is covered in sulfur volcanoes. Its surface is constantly reshaped by sulfur-driven eruptions. If life exists elsewhere in the universe, it may rely on sulfur chemistry, just as early life on Earth once did. Sulfur forces us to rethink what habitable means. Life does not require Earth-like conditions. It requires chemistry, energy, and time. Sulfur expands the boundaries of where life might exist, but sulfur is only part of Earth's deeper story. In our next episode, we journey to the planet's core, to nickel, the hidden partner of Earth's heart, the element that helps generate our magnetic field and shields life from deadly cosmic radiation. Sulfur thrives where life should not exist. It powered the first living systems. It sustains life in the darkest places on Earth, and it may guide us to life beyond our planet. If this story expanded your understanding of life and the universe, please subscribe and like. Your support helps us create more cinematic science stories about the elements that shape existence itself.